Undoubtedly, whether it involves exploring a star's nascent phases, primitive galaxies, or locating traces of life on other planets, the phenomenal role that NASA's observatory telescopes have played in this regard is undeniable. For instance, the world's first space-based optical telescope, the Hubble telescope, launched in 1990 and named by NASA after the famed astronomer Edwin Hubble, played a prominent role in advancing the field of galactic astronomy during its 3-decade run. From sending us mind-blowing and ethereal, breathtaking images, including those of the Pillars of Creation and the Lagoon Nebula, to confirming the existence of galaxies mired with black holes, the telescope has revealed some of the most fascinating mysteries in the galactic space beyond our own. However, everything evolves over time, especially in science. One invention takes over another every day. This simple statement also seems to ring true for the Hubble Space Telescope, as it is now being taken over by a successor, which is much stronger and has greater specs, known as the James Webb Space Telescope. So, if you are a die-hard fan of the Hubble telescope and assume that it can still beat its successor, the James Webb Space Telescope, think again. Yep, that's because we believe the Hubble Space Telescope can't beat the James Webb Space Telescope ever, period. If you want to know why, keep watching to the end of this video. Also, if you want to know the latest news on the James Webb Space Telescope, NASA, and other space updates, click the like and subscribe buttons. With that said, let the James Webb Space Telescope intergalactic travel begin. Coming back to the point, if you were wondering, but how can't the Hubble telescope beat the James Webb Space Telescope? Here are several ways that the JWST surpasses Hubble and marks itself unbeatable. Number 1. First of all, the JWST telescope beats Hubble in terms of its size. So, whereas the Hubble is about the size of a 40-foot container that can easily fit up to 5 cars, the Webb is about 1/5 as long as a cricket pitch. If that isn't convincing enough of the amazing powers the JWST holds over Hubble, there is also a stark contrast in mirror sizes of both of these telescopes. That is, the Hubble telescope's round mirror stands at 7.8 feet in diameter. In comparison, the JWST, which is shaped like a hexagon, covers a diameter of 21.3 feet. As a hexagon provides a wider area compared to a circle, JWST collects 6 times more light area than Hubble. If you are thinking, what's the importance of the size of a mirror? Or what has collecting light have to do with the superiority of JWST over Hubble? Worry not, we've got you covered. To put it simply, in order to observe objects that are very far in space, telescopes require more light to see these celestial bodies. Therefore, when it comes to space telescopes, the most important feature that makes the James Webb Space Telescope unbeatable by Hubble is the size of its curved mirror. The mirror acts like a bucket collecting light, which means that JWST's mirror collects more light and can see objects that appear fainter to other telescopes, such as Hubble, far more clearly. Extraordinary, right? Number 2. Secondly, talking about light, it is important to note that there are different varieties of light that help to view objects differently in space. For instance, humans can only see a light called visible light. Apart from this visible light, there exist higher forms of light, including ultraviolet light, X-ray, and gamma rays. And then, these lights are further succeeded by an even more powerful light with the longest wavelength known. This is infrared light. Infrared light is crucial to unraveling the hidden realms of space. This is because when a light source starts to move far away from its original location, it starts to expand, morph, and stretch into longer and longer wavelengths, ultimately becoming red. Think of this phenomenon as similar to what happens when a warning bell goes off. The pitch increases as the warning siren approaches, then decreases as it trails away. So, because everything in space is continuously twirling, moving, and expanding, the furthest things away from us start stretching and ultimately turn into red dots. To view these red dots, or older galaxies, infrared radiation is the only light that can help, as this light is the only one that can tread through cosmic dust, which scatters all other lights, including the blue or visible light emitted by the gamma and ultraviolet rays, and make it impossible to observe older galaxies. Therefore, the second reason that Hubble can never beat JWST is that Hubble views light at 90 to 2005 nanometers and can only observe blue light of the gamma and ultraviolet rays, and at times a little bit of infrared light. Meanwhile, the James Webb Space Telescope takes this a lot further and views light at 600 to 28,500 nanometers, including gamma, X-ray, infrared, and ultraviolet light. This superior power allows James Webb Space Telescope to observe very old galaxies that have never been explored before. In doing so, the JWST also allows astronomers to not only explore space, but also tread back in time. If you are thinking if this is possible, can a mere telescope or the James Webb Space Telescope give information about the past? The answer is yes, it absolutely can. This is proven by what the James Webb Space Telescope captured in a deep field image of a distant galaxy that had never been seen before on its very first day. If this isn't mind-blowing, then we don't know what is. Due to this feat, astronomers like Kaylee Casey, who works for the Webb Space Telescope, believe that JWST can explore galaxies that emerged 250 million years after the Big Bang, and can see 13.6 billion light-years away, whereas in comparison, the Hubble Space Telescope can see about 10 billion light-years away. To give you a visual narrative, the Hubble Space Telescope, after 5 years, succeeded in staring at a tiny patch of space that gave the illusion of a single grain of rice held at arm's length. On the other hand, on July 12th, the James Webb Space Telescope made history by releasing its debut image, known as the Jewel-Filled Photo, due to several hidden galaxies behind what appears to be a single cluster. The discovery of these year-old galaxies is the reason why this jewel image has been awarded as the deepest photo of the universe ever taken. And the best part of this photo? It was taken within just the first 12.5 hours after the JWST was launched. Now that is an extraordinary achievement, right? What is also mind-blowing is that the first image released by JWST succeeded in focusing on an even smaller slice of the sky, which included a vast array of galaxies and, from afar, looked like a part of the sky only the size of a grain of sand held at an arm's length, which in comparison equals a fraction of the size of the field covered by the Hubble telescope. Unlike Hubble's field image, the image by JWST was intentionally focused on a certain galactic cluster named SMACS 0723. If you zoom in on the image, it shows a cluster of larger, whitish galaxies sitting just near the center of the image that is believed to have first appeared around 4.6 billion years ago. This means that the light you are witnessing right now was emitted a short while before planet Earth was formed. Absolutely mind-blowing, right? To put it more simply, the image you are currently viewing awakens an understanding that there is no empty space in the sky, as was previously believed based on the images procured by the Hubble Space Telescope. In this light, because one of NASA's biggest goals is to study the oldest light in the universe, the JWST emerges as one of the most powerful telescopes that allows us to look back in time without missing out on the thousands of younger, closer galaxies that we missed before. If this doesn't make you side with the JWST, we don't know what else will. Number 3. Thirdly, in addition to providing a greater detail of spatial images, another thing that makes JWST unbeatable by the Hubble telescope is that JWST does not orbit around the Earth. Yep, you heard that right. Rather, this space telescope orbits around the Sun at 1.5 million kilometers, which makes up up to 1 million miles away from Earth. This point of orbit is what is called the second Lagrange point, or L2. The L2 orbit is very important in this context because it allows the telescope to stay in line with the Earth as both move around the Sun. This strategy allows the satellite's large sun shield to protect the telescope from light and heat of the Sun and the Earth that could destroy its instruments immediately. Therefore, instead of sitting stationary at L2, the JWST continues orbiting around it, which results in keeping the telescope out of the shadow of the Earth. This helps the James Webb Space Telescope to have an unimpeded view and allows the telescope to engage in scientific discoveries around the clock. In contrast, the Hubble telescope goes in and out of Earth's shadow every 90 minutes, and this hinders its scientific operations. Number 4. Last but not least, the James Webb Space Telescope's position at L2 orbit makes it easier and much faster to download data and images and send them to Earth. Since it is orbiting at a close range and near the midnight sky about 1.5 million kilometers away from Earth, the James Webb Space Telescope provides continuous communication, which makes the transmission of data much easier. Due to the close proximity, according to NASA, it takes about 5 seconds for data to reach the James Webb Space Telescope from Earth. On the other hand, the Hubble Space Telescope, since its orbit is 569 kilometers above the Earth's surface, takes only 2 milliseconds for data transmission. However, Hubble doesn't directly send data to Earth. Rather, it sends the data first to the TDRSS, causing a significant delay, and hence, it takes significantly greater time than the James Webb Space Telescope. With that said, which is one of these stark differences between the Hubble and the James Webb Space Telescope, have you been convinced that the Hubble Space Telescope can't beat the JWST? Let us know in the comments section below. If you enjoyed watching this video, press the like button and tap the subscribe button to stay notified. And keep watching amazing videos about space telescopes, NASA news, and other space updates. See you in our next video.